Hey guys, and welcome back to another video on the channel. Welcome to pretty much part 3 of the Math Methods 2021 Paper 1 short response. So this video is going to be a lot shorter than previous ones, so we just didn't pretty much have enough time. Otherwise the video would have been too big for the part 2. So we're just going to be doing question 20, and let's just get straight into it, okay? The population of rabbits P on an island in the hundreds is given by this equation, where T is the time in years, okay? Determine the interval of time when the population is increasing and the intervals when it's decreasing, okay? So with this one here, when they say the population is increasing, that means when the rate of change is positive, okay? So in this equation here, because it's P and it's a function of time, we want to know when dP dt is positive, okay? Now, and we also want to know the intervals when it's decreasing, so we want to know also when dP dt is negative, okay? Now, if it's positive and negative, that means we have some sort of thing like this, okay? So we have pretty much positive, well, we probably have like one of these hills here, so we have something like this probably, or something like this. So here, this would mean a positive rate of change, because it's increasing, and then here this might be a negative rate of change, okay? Because it's decreasing, so the tangent lines would be facing the other way, okay? So to understand what we have going on here, we need to understand, alright, why it's positive. The tangent lines would be facing this way, so here the gradient is positive, then it'll be 0, then it's down like this, okay? So we need to know, alright, we need to find this stationary point, and then we need to work out, alright, which side is positive and which side is negative, okay? So that would be determining, alright, whether it's a maximum or a minimum, okay? So there's going to be a lot we're going to have to do with this question here. We need to find the first and second derivative. The reason why we need the second derivative is because we need to know, alright, is it a maximum, is it going from a positive to a negative, or a negative to a positive, okay? So, first of all, just start differentiating, okay? If you didn't know what to do in this question, just start differentiating, okay? So P, oh, let's write it in blue so it's a bit better. So P is T squared ln 3T plus 6. So here, this guy is going to be a product rule. So here, you have to differentiate one, leave the other, and then add it together. So here, I will differentiate this first, leave that, and then differentiate that second. The differential of 6 is just going to be 0, rate of change of a constant is nothing, so dP dt. So product rule, rule. You don't have to write this, I'm just writing this so in case anyone mistakes what I'm actually doing here. So here, this is going to be 2t, then this is going to be ln 3t. That's going to be plus t squared. Now, the derivative, so derivative of this guy here, doesn't matter what number's there, it's still going to be just 1 over t, okay? Because remember, to differentiate this is a chain rule. The derivative of the inside function would be 3, and the derivative of the outside function would be 1 over 3t. So here the 3's cancel out, so it's 1 over t. If there's a plus in here, so if it's this, then that's slightly different. That would be, 3 over 3t plus 1. The 3's wouldn't then cancel out. But if it's like this, it's just going to be 1 over t. So here, we're going to have t squared times by just 1 over t, and that's it, because that would be 0, okay? If you have any questions about that, leave something in the comments, and I'll try my best to answer it. So, let's continue here. Now we're just going to find the second derivative, so we're going to clean this up a little bit. So dP dt, that'll be 2t ln 3t, and that's going to be just plus t because we have a t squared here and we are dividing by another t, so it's just going to be plus t. So let's just differentiate that again. So another product rule, and that turns into 1. So d squared dP will be 2 ln 3t plus 2t times by 1 over t plus 1. So we'll just clean that up. So second derivative, so we'll have 2 ln 3t plus 2 plus 1. So that's just going to be a plus 3. Okay. So here your second derivative will be 2 ln 3t plus 3. Okay. Now, we need to find some stationary points because we want to know when the first derivative is positive and negative. To do that, we need to know when it changes from a positive to a negative. So we can have this situation here, or we can have this situation here where it goes from a negative rate of change to a positive rate of change, okay? And the only way to work that out is, alright, finding that stationary point and determining the nature of that stationary point, whether it's a concave down like this one here, or a concave up, okay? Now, if it's concave down, if it's going from a positive rate of change to a negative rate of change, this means the second derivative must be negative, okay? And if it's concave up, where it's going from a negative rate of change to a positive, the second derivative must be positive, okay? So let's do this real quick. So stationary point, the first derivative is 0. So dp dt is 0 for a stationary point. So set this equal to 0, so you have 0 equals 2t ln 3t plus t. Now this is without a calculator, okay? This isn't actually too bad, okay, if you're good at your algebra. So first of all, try and get t by itself. Now obviously this looks a bit tricky at first, but we can move this t across, so we have negative t equals 2t ln 3t. Now you can see, if I divide both sides by t, it's going to get a whole lot easier. So here, we have a t equals 0, okay? That's important to take note of. So as soon as I'm dividing by t, I have one solution at t equals 0, so keep that in mind. Then, I'm going to have negative 1 equals 2 ln 3t, okay? Divide by 2, so we have negative a half equals ln 3t. Now ln is log base e, so rearranging this will be 3t equals e to the negative a half. Now e to the negative a half is the same as 1 over the square root of e, okay? Move the 3 across, so when t equals 1, 3 root e, that's a stationary point, and we also have when t equals 0, okay? So found the stationary points, we've got marks. So now, we've got to determine, alright, if it looks like this, and looks like this, okay? So here, we'll go t equals 0, and then what's the other one? T equals, I forgot already, 1 over 3 root e. So here, we've got to use our second derivative now, so the second derivative, so dp that squared, so let's go up and just see that. Alright, so we'll write that, so 2 ln 3t plus 3. So we'll just chuck in the first one. So here we'll go t equals 0, goes in here, so we'll go the second derivative when t equals 0. So now replace t with that number, so 2 ln 3 times by 0 plus 3. So you can see where I've just chucked that fella in there right there. Now ln of 0 is undefined, so here you can just say this term doesn't really exist, okay? So it is undefined, it is not 0, but in this case here in our syllabus we have to say it's 0 because it is undefined, because remember the log curve looks like this, it doesn't touch when x equals 0, so that term just goes away. So you get the second derivative is just positive, okay? It's positive 3. I don't care what the number is. All I know is when t equals 0, the second derivative is positive, okay? So what that means is this is a minimum, okay? So keep that information in mind. Now let's do the same thing with the other one. So dp, the second derivative, when t equals, what's this monstrous number? 1 over 3 root e. So you have 2 ln, and then you have 3 times by 1 over 3 root e plus 3. So here you can clearly see the 3 is going to cancel out there quite nicely. Now we're going to rewrite, so 1 over the square root of e, we know is e to the power of negative half. Now the reason why we want to write it like this is because it's going to be easy to sort out here, okay? So if we simplify this, we'll have 2 ln e to the negative a half plus 3, okay? Now, log ln is log base e. So you can see you have ln of e and an e in there. So that's going to cancel out quite nicely, but you've got to bring this power out the front. So you have 2 times by negative a half, and ln of e, this term is just going to be 1. Because remember, log of that same number will always be 1. So log e of e is 1, which is the same as ln of e. Okay. Then we would have 2 times negative a half plus 3. So here you get negative 1 and then plus 3, and you also get 2. Okay. So what that means is that this number here, oh wait, is it 2 negative half? Oh, okay, I must have made a mistake on my actual physical working here then. Oh no, wait. No, wait. Just double checking here. Yeah, I did make a mistake. It is positive 2. Okay. I had it as positive 1. Just a little error there. So that means the second derivative at this point here is also positive. Okay. So we can just say when t equals that. So 1 over 3 root e. The second derivative is positive. Okay. Or greater than 0. Okay. So that means, now we also know when t equals 0, it's positive. And we also know when t equals that, it's also positive. So we have two stationary points, okay? So we kind of have two maximums. So we have when t equals 0, it's a, that's a minimum. And that's also a minimum. So they're both minimums. So at t equals 0 and t equals that, they're both minimums. So that means we have this situation like this. So what that means is, if they're both minimums, then anything beforehand would be positive. So here we would have to say, before t equals 0, it would be a negative rate of change. Then afterwards, it would be a positive rate of change. Oh, so we won't use that color because that's already there. So this is how I would answer this question here. So because at t equals 0, it looks something like this. And at when t equals, why did I use that color? Oh, it just must have defaulted to that. So when t equals 1 over 3 root e, I would say when t is less than, when t is greater than 0, the first derivative is positive because it turns into positive. We can see from this definition of minimum. And when t is greater than, we would say 1 over 3 root e, the first derivative is also positive. Now we've also got to say when it's decreasing as well. Now this is where it gets a bit blurry here because we only have two stationary points, okay? We have two minimums, so like this, okay? In the middle, we have to assume, like if it goes like that, there will be a point, there has to be another stationary point we haven't accounted for. So if we go back here, is there anything else we haven't? So we move that across. So we had t equals 0. No, you should only get two stationary points. Yeah, I would say those are the only two values where there are stationary points. Maybe there's an error with this stuff here. So we chucked in t equals 0. Is that a positive or negative at the back? That should be, that one's fine. That one's still fine there. Just double checking my working here, so I'm all good. I can double check the answers as well here. I'll just pull them up as well. So we'll go QCAA. I like to do this in one tank. I don't really care. Let's go here, secondary school. You probably won't be able to see this. You're probably still stuck on that screen, which is good. Let's go here, methods, past papers. We'll go, this is 2021 marking guide. So question, what was it, 12 or something? Okay, cool. So here, yeah, we've got that stuff here. So, oh, okay, gotcha. So we do have the right numbers. Now, what they've said is it has to be between 0 and that number we just got given there. Now, they had when t equals 0, reject. Oh, okay, so I've seen the error I might have made here. So this error is actually quite tricky to spot. But here, when we chuck in t equals 0, because this is undefined, we can't really say it's positive, okay? So we kind of have to assume, alright, that's a stationary point, but we don't know if it's a max or a min, okay? So if we know it's a stationary point here, when t equals 0, and it becomes then, what's it called, another minimum, then it's going to be a positive rate of change between 0 and this number 1 over 3 root e. And then you have to say t is, when t is greater than 1 over root 3e, then it's decreasing. Here, I'll just double check their stuff as well. So the population other way. My mistake there. I was right the first time. So here, this is when it's decreasing. and then whenever it's bigger than that, it is increasing, okay? Because remember, so here we can't assume that's a minimum, but we know that's a stationary point there, okay? So here, we've got something like this, like that. This is when t equals 1 over 3 root e, okay? So it will be a positive rate change when it's greater than this number, because it has to look something like this. Beforehand though, between these two values, it has to be decreasing, so that's accounting for like that shape there, okay? Sorry for a little bit of confusion in that video, but all this working is still correct. So even if you didn't get that like that little interval right, you would probably still get 6 of the 7 marks, but that's how you answer that question, okay? If you have any questions at all with this one here, leave something in the comments, but I'll see you in the next video, okay? Sorry this one took a couple of days. Just making videos for everyone, okay? See you later.